When you stub your toe, you'd swear the pain is in your foot. It's not. There is no pain in your foot. There is no pain anywhere in your body. The conscious feeling of pain is created entirely inside your brain, manufactured from danger signals, predictions, memories, and context. And your brain can turn it up, turn it down, or fabricate it from nothing. Pain is the most convincing perception your brain produces, and everything you think you know about it is wrong. Your body is covered in specialized nerve endings called nociceptors, from the Latin word nocere, to harm. They're in your skin, your muscles, your joints, your organs. But here's what most people get wrong. Nociceptors don't detect pain. They detect potential damage, pressure, extreme temperature, chemicals from injured tissue. They send a signal that says, possible danger here. That's it. The signal travels up sensory neurons to the spinal cord, but the signal itself has no pain in it. It's an electrical impulse identical in form to any other nerve signal. Whether that signal becomes pain, whether you actually suffer, is a decision your brain makes after evaluating dozens of other factors. In 1965, Ronald Melzack and Patrick Wall proposed the gate control theory of pain. The spinal cord contains a neurological mechanism that acts like a gate. It can amplify, reduce, or block danger signals before they reach the brain. This is why rubbing a bumped elbow helps. The touch signals from your hand travel on faster nerve fibers and arrive at the gate first, partially closing it to the slower danger signals coming from the bruise. It's also why distraction works. Cognitive activity, focusing on something else, sends descending signals from the brain that close the gate. And it's why soldiers wounded in battle sometimes report feeling no pain until hours later. Their brain, flooded with adrenaline and focused on survival, slammed the gate shut. The injury was real. The pain was postponed. If a danger signal passes the spinal gate, it reaches the brain, but it doesn't go to one pain center. There is no pain center. The signal is distributed across multiple brain regions simultaneously. The somatosensory cortex processes where the signal came from and how intense it is. The insula processes the emotional unpleasantness. The anterior cingulate cortex adds urgency. The prefrontal cortex evaluates context. Is this dangerous? Should I worry? The amygdala checks for past associations. Have I been hurt like this before? Only after all these regions weigh in does the brain construct the experience of pain. This means pain is not a sensation you receive. It's an opinion your brain generates. And like any opinion, it can be wrong. Studies have shown that identical stimuli produce dramatically different pain experiences depending on context. In one experiment, participants received the same mild electric shock. Those told, "This is a medical test," reported less pain than those told, "This is to see how much you can handle." The expectation changed the experience. In another study, volunteers who could see a red light during a freezing cold stimulus reported more pain than those who saw a blue light, even though the temperature was identical. Color changed pain. Perhaps most remarkably, when researchers put a fake price tag on a placebo painkiller, participants who thought the pill cost $2.50 reported more pain relief than those told it cost 10 cents. Same sugar pill. The expensive one worked better. The most powerful proof that pain is a brain creation, phantom limb pain. Up to 80% of amputees experience pain in the limb that was removed. They feel their missing hand cramping, their absent toes burning, their non-existent fingers being crushed. The body part is gone. The nociceptors are gone. The nerves are gone. But the pain is absolutely real, because pain was never in the limb. It was always in the brain. The brain's body map still includes the missing limb. And when the expected sensory input doesn't arrive, the brain sometimes interprets that silence as danger and generates pain to match. Neuroscientist V.S. Ramachandran developed a remarkably simple treatment, a mirror box. The patient looks at the reflection of their intact hand where the missing hand would be and moves it. The brain sees a hand moving painlessly and updates its map. For many patients, the phantom pain vanishes. Acute pain has a purpose. It protects you from damage. But chronic pain often persists long after the original injury has healed. The tissue is repaired, the inflammation is gone, but the nervous system has been rewired. This is called central sensitization. the spinal cord and brain lower their threshold for pain signals, amplifying normal sensations into agony. Touch that shouldn't hurt does hurt. This is allodynia. Mild pressure that should barely register becomes excruciating. This is hyperalgesia. The alarm system is broken, stuck in the on position. Chronic pain isn't the old injury still hurting. It's the nervous system itself that has become the problem. Treating chronic pain requires not just addressing the body, but retraining the brain. If placebos can reduce pain through expectation, the reverse is also true. The nocebo effect. Expecting pain creates pain. In studies, patients told that a harmless injection would be painful reported significant pain, complete with measurable changes in brain activity and stress hormones. Their bodies mounted a genuine physiological response to something that should have caused none. In clinical trials, patients reading the side effect warnings of medications report those exact side effects. Even when they're taking the sugar pill, expectation doesn't just modify pain, it can manufacture it entirely. Here's what's practical about all of this. Pain neuroscience education, simply teaching people how pain works, has been shown to reduce chronic pain. When patients understand that pain is an output of the brain, not a direct measure of tissue damage, their nervous systems literally calm down. Understanding that a sore back doesn't necessarily mean a damaged back changes the brain's threat assessment. The pain decreases. Not because of a drug, not because of surgery, because of knowledge. Your brain's opinion changed, and pain is an opinion. The next time you stub your toe and feel that sharp, hot, unmistakable pain, remember, your foot is just sending a report. Your brain is writing the headline. And sometimes the headline is wrong.